Does grain size predict material failure? Imagine a tiny world inside metals where the size of grains can influence whether a piece of metal holds up or breaks apart. Today, we're going to explore if the size of these grains can actually predict when a material might fail. In metals and granular solids, the size of the grains in the microstructure plays a big role in how the material behaves under stress. Smaller grains tend to make the material stronger because the boundaries between grains act like barriers that slow down dislocation movement. Dislocations are tiny defects that move through the metal and cause it to deform. When grain boundaries block these dislocations, the material resists deformation better. This is known as the Hall-Petch relationship. But does this mean that smaller grains always prevent failure? Not quite. While finer grains usually increase strength, they can also change how cracks form and grow. Smaller grains often make the material more ductile, meaning it can absorb more energy before breaking. Larger grains, on the other hand, tend to make the material more brittle, which means it might crack suddenly with less warning. The distribution of grain sizes also matters. If a material has a mix of small and large grains, it can be tougher because cracks may slow down or change direction when they hit different grain sizes. This can help prevent cracks from spreading quickly and cause the material to last longer. In failure analysis, metallography is used to look at the microstructure of the material. By examining the grain size and how the grains are arranged, engineers can get clues about why a part failed. For example, a microstructure with very fine grains might show a sudden brittle fracture, while coarse grains might be linked to ductile failure. Understanding grain size helps in designing better materials. By controlling how grains grow during processes like heat treatment or mechanical working, manufacturers can improve the strength and toughness of parts. For example, refining grain size can make a component more resistant to breaking under stress. So, does grain size predict material failure? It definitely influences it. Smaller grains can increase strength and toughness, but other factors like grain distribution and the type of stress also play a part. Metallography gives us the tools to see these microstructural clues and understand how they relate to failure. This knowledge helps us improve materials and prevent future failures in everything from bridges to airplanes.